Point three, operations with radical expressions. I think you'll find that we've kind of highlighted or maybe briefly touched on a lot of these ideas today. So kind of the three main things we're going to be doing: adding and subtracting radicals, and we'll be doing a little bit of multiplying as well. So to start off with the vocabulary word, we've got the word radicand. And radicand is essentially the stuff that is inside of the radical, right? We know the radical is like the square root sign, so anything that's underneath of that or inside of it. The mathematical term for that would be radicand. So just keep that in mind as we go through here. As we look at kind of the three examples down below, we know from past experience in 10.2 that we can multiply regular things with regular things, and we can multiply radicals with radicals, right? The things in jail can go together, and the things outside of jail can go together, but we shouldn't mix them. So if we look at the three examples, we start over here to the left, we've got the square root of 2 and the square root of 3, both in radical form, so I can combine those to make a larger radical at the square root of 6. Kind of a similar idea in the middle example, example number 2, I've got 3 square roots of 2 times the square root of 8. I can multiply the square root of 2 and the square root of 8 together to get the square root of 16. The 3 just kind of has to hang out in front, sort of outside of jail. I know a more easy or more simple way to write the square root of 16 is 4, so 3 times 4 would be 12 for the final answer there. And the last one is a division example. Remember, like I can simplify the regular numbers with the regulars. I can simplify the radicals with the radicals. So 6 divided by 3, the two regular numbers there, that's how I got to 2. And then the square root of 12 divided by the square root of 4, that's how I got to the square root of 3. So just kind of push those two things together to get 2 square roots of 3. Adding and subtracting, kind of like when we combine like terms, are more strict. So I always think of the radicals like last names, right? Like variables like X or Y or M or N, all the different variables that we work with throughout the year. And those variables, those radicals in this case, have to match exactly. So like in the left example, the square root of 2 plus 3 square roots of 2, I can think about that as, okay, I've got 1 square root of 2 right here. I've got 3 square roots of 2 right here. If I combine those together, I'm going to have 4 total square roots of 2. So you can see kind of right there that it's really, really similar to like if I had x plus 3x, I would add those together to get 4x. So really kind of the same exact idea. Down below, 6 square roots of 3 plus 4 square roots of 3. Add up kind of like the coefficients, the regular part, to get 10. Keep your last name at the square root of 3. So 10 square roots of 3. There we go. Just an example that wouldn't work because I've got the square root of 3 over here to the right. I've got the square root of 3x. Not like terms, can't combine them, so that would just be as simple as possible. So I'll write the word simplified. All right, it's not too bad when the radicals match right away. Really pretty easy, really, really similar to combining like terms. An example right here, maybe I'll kind of lead the charge here, and then we've got slide number 4 that you guys kind of try. So example, I've got 5 square roots of 2 plus 7 square roots of 2 minus 6 square roots of 2. All the radicals match, so that's good. That means I can go ahead and combine kind of like the coefficients, the regular numbers. If I work 5 square roots of 2 plus 7 square roots of 2, I get 12 square roots of 2. And if I bring down this minus 6 square roots of 2, looks like my total would be 6 square roots of 2. Pretty easy, not too bad. Keep the last name the same, right? Keep the radical part the same and just operate with the coefficients. Why don't you guys go ahead and try this example. If you need to pause the video to do that, feel free, but work it out, see what you get. And I will continue on here. All right, welcome back. I've got 6 times the square root of 11x plus 2 square roots of 11x minus 9 square roots of 11x. So again, notice how all of the radicals match. That's good. That's a benefit for us. It's less work for us if that's the case. I've got 6 plus 2, which is 8. Keep the radical the same, square roots of 11x minus 9 square roots of 11x. So all in all, it looks like I'd have, if you're a junior or just realize that you're pretty good with integers, negative 1 square roots of 11x. I know that most simply written would just be negative square root of 11x. So I'm going to try to get all the way as simple as possible down to that. All right, example 5 gets a little bit tougher. So now notice with the problem that we're working with, 4 square roots of 54 plus 2 square roots of 24, our radical parts don't match. right? And we'll run into that, obviously. Not everything's going to come out and be perfect for us. So we're going to have to be creative and make sure that the number that stays inside the radicand in this case, right, that math vocabulary word from slide 1, stuff inside of the radical, we want that to stay the same. I've kind of helped you out with the factors of 54 and 24 over here and over here. And if you look, kind of make your way down the list, the things I've got highlighted there in blue, that's like the non-perfect square factor that would stay inside and be the radicand. Notice that the 6 matches this 6, that's why I have it in blue. And then the 9 and the 4, those are the perfect square parts of the factoring that we'd be able to bust out of jail to make the radical more simple. So let's kind of take and transform this and see what it looks like. So 4 square roots of 54. I'm going to rewrite that as 4 square roots of, I'm just going to say 9 times 6. Okay. Plus 2, rewrite the square root of 24 as 4 times 6. Again, notice these 6's matches. These are the parts that are not the perfect square from the factoring. So those are the things that are going to stay inside. That's the key. We've got to make sure the things that stay inside are the things that match. So if I square root 9, bust down of jail is a 3. That gets me 4 times 3, which is 12 on the outside. Square roots of 6 plus square root of 4 inside. It becomes a 2 when you bust it out of jail on the outside. 2 times 2 on the outside is 4. Square roots of 6. So now we're back to a similar situation to the 4th slide and the 3rd slide where we've got the radicals that match, right? The radicands are both 6, they match. We can go ahead and combine like terms. 12 plus 4 is 16. Keep my last name or my radical the same at the square root of 6. So that would be my final. So again, emphasize making the number that stays inside the radicand, emphasize that being the same thing. So you should have the one that matches. In this case, it was 6 for us. The other factor needs to be a perfect square, like 9, like 4. All right, example number 6. We've got 2 square roots of 18 plus 2 square roots of 32 plus the square root of 72. All right, so if I think about 18, really the only thing that I could come up with a perfect square factor would be 9 and 2. So I'm going to take 2 square roots of 18 and rewrite that as 2 times the square root of 9 times 2. Plus sign. If I think about 32, I've got like 1 and 32, doesn't really help me there. 16 and 2 could be super nice because 16 is a perfect square factor, and then the 2 would be the number left inside, and that would match what I've got from the 2 square roots of 18 that I just did. So let's go 2 times the square root of 16 times 2. All right, plus square root of 72. First thing that comes to mind is to try to keep a 2 in there. So I realize that that could be done by splitting that up to 36 times 2. Nice, because 36 is a perfect square. So I've got the case where I've got perfect square, perfect square, perfect square. To bust those out of jail in just a second. I've also got matching, matching, matching with my 2's. So 2 on the outside, if I've square root 9 to get 3 on the outside, 2 times 3 is 6 square roots of 2, plus 16 becomes a 4 when you square root it and bust it out. 2 times 4 is 8 on the outside, square roots of 2, plus 36 becomes a 6 on the outside, nothing to multiply that with, so I'll just write 6, and then square roots of 2. So you can see by kind of manipulating 18, 32, and 72 to 9 times 2 and 16 times 2 and 36 times 2, now I've got it where all of my radicands match. That's all 2's. So 6 and 8 and 6, we've got 12 and 8 is 20. So 20, keep my last name the same, square roots of 2. All right, example 7, why don't you guys pause the video, give it a try. 4 square roots of 12 minus 6 square roots of 48. When you jump back in, I'll be working through it, kind of check your work with mine, make sure that you match up. All right, welcome back. We're working with 4 square roots of 12 minus 6 square roots of 48. If I think about 12, really the only thing that comes to mind there would be 4 times 3. So I'll do 4, make 12 become 4 times 3. Minus 6, and then I want to try to keep this 3 inside for that 48. So I know that 16 times 3 would be 48. So 16 is my perfect square, and then the 3 is going to be the factor that matches. So there's my matching 3's. If I square root 4, comes outside as 2. 4 times 2 is 8 on the outside. Square roots of 3 minus. If I square root 16, it becomes a 4 on the outside. 6 times 4 is 24. Square roots of 3 left over in the radical. A little bit of an integer problem. If I do, gosh, what is that? Negative 16. Square roots of 3. And I have it there. Our last one, a little bit of, I don't know, maybe kind of a challenge problem. Think about the fact that you've got 1, 2 terms times another 2 terms, looking like a FOIL type of problem. And we also have a little bit of division. So just kind of reviewing, I don't know, maybe some more similar ideas from like 10.2. But with a FOIL, do my first. 4 times 2 is 8. The square root of 3 times the square root of 3 is just regular 3. So 8 times 3 for that first part of my FOIL. If I go to the outer, I'm just going to keep the 4, looks like a plus sign. And then the square root of 3 times the square root of 6 would be the square root of 18. Inner. Looks like, again, positive. So 2 is going to hang out because it's kind of by itself, but the square root of 6, the square root of 3 becomes the square root of 18. Well, that's nice. Notice we match there. And then the last part of my FOIL, both positive, so a plus sign, the square root of 6 times the square root of 6 would just be regular, normal 6 without any sort of a radical. I'm going to rewrite 8 times 3 is 24, plus 4 square roots of 18, plus 2 square roots of 18, plus 6. I can combine my like terms. 24 and 6 make 30. And if I put these two together, right, radicals match 18 and 18. 4 plus 2 is 6. Keep my last name, the square root of 18. Now, one further thing that I could do here, and maybe some of you were thinking about this, is 18 could be rewritten as more simple, right? We could make it 9 and 2. So 30 plus 6, rewrite 18 as 9 times 2. 30 plus, if the 9 comes out as a 3, 6 times 3 is 18 out here, square root of 2 left over inside. I believe that would be as simple as we could make this problem. Okay. Your job right now is to get the 10.3 worksheet, and you're going to do all of the problems. Mikey's over in the usual spot by the document camera. Feel free to check that over. Best of luck. Have a great weekend, and we will see you guys on Monday.